Good day, everyone. My name is Okpa Odusheso from KGIS. This week, an urban regional planning student from Imo State University said to me that there was a file that was given to him to work on by their lecturer in school. But I don't know, maybe they are the one that digitized the map, or it was given to them. But one told me is that the map, it is out of proportion. What I mean out of proportion is that he said the width of the road are perfect, whereby the size of the building are bigger than what it is expected. For example, he said he was trying to measure a specific density, a low density, let me say the low density. Then he now sees that after he tried to measure a low density, and he told me that the low density in what they give them in their school is 25 meter by 30 meter. Then for you now to get a block of a low density, now we should be like a 60 meter breadth, and you now be dividing it by 25 meter. Then when he tried to measure the 60 meter breadth, it is smaller than the even the existing building on the site. They are now wondering that how will such a thing happen, whereby a single unit of a building will be bigger than a breadth of a super block. Then he asked me to help him to do this thing. That's why I now say, okay, let me use it as a this week lecture, so that in case you might have encountered this kind of issue before, or you maybe in the future you might encounter this kind of problem now, then with the help of this, what I'm going to do now is going to be helpful for you in a subsequently. What thing you just have to do is that, okay, I'm going to launch the AutoCAD format that he gave to me, and this is the name of the AutoCAD format that he sent to me to help me to do. I'm going to launch it. Then as I'm launching it, I will also be launching my Google Earth. But one thing is that I tried to ask him about the location of the site. Then he told me that the site, let me just try to show it to you, so that he said the site is is first somewhere around Imekuku. Imekuku is a place in Imo State. Then I'm going to try to look for the name of this road in Google Earth, so that I will be able to use to solve this problem of what he asked me to do for him. For example, now what you just have to check is, now let us check. Let me press D high, which is distance, and then let me try and measure the breadth of this building. You see, you can see this single unit of a building now, it is almost like that 39.32 meter. I'm very sure is a residential building. Then I don't think that a residential building, unless if it is a very a multi-purpose building, that will be up to the breadth of the building will be up to 39 point something meter. And if you check the length also, now you see it's more like 65.63 meter long. It's very long. It's very long. Even if you are a civil a structural engineer, you are going to design this kind of thing. There's a highly proper measures that you have to put into consideration before you can even structure this kind of building. Now you can see, now I try to measure this kind of building. I mean, this particular building. Now if you see now the distance, we are getting almost like 132.82 meter. It's very long. I won't lie for you. Then if you try and check this width of the road, if you see, we are getting almost like a 35.77 meter in Nigeria Hill Road. Then I'm not saying it is not, it's a minor road. It's not even there's some express in Nigeria is not even up to 35, compared to like a road within a neighborhood. Then initially, because to be on the safer side, I've already try and save the place. This Emekuku, because I've already launched my Google Earth before, then so that I won't need launching it again. Because like now I didn't connect my Google with network, but I've already launched it before. Then now I've already saved this Emekuku locality in Google Earth. Then I've already clicked on it, and it's now going to show me where the the thing is. Then let me try and maximize it. You can see, if you try and see Imbaeze Road, then the same thing we have here, Imbaeze Road here, Imbaeze Road. Then let's try and use the configuration of this road pattern to determine how the things look like, if what we have in Google Earth and what we have in AutoCAD are the same. For example, now let's just try and check. I'm zooming out in Google Earth now. Can you see now that this is a road? Then on AutoCAD format, then the same thing now, you can see the configuration of the road. This is Imbaeze Road, and the same thing in Imbaeze Road that go this way. If you check, we'll see how the thing goes. You see, you can see how this one also goes. It has a bend here. You can see now that was the same thing as. Then if you try and check the configuration here, you see there's a fork junction here. On this, then the same thing happened here. This road go this way, whereby that this one also go this way. This one come this way, whereby this one goes this way. This one come this way, this one goes this way. Then let us go further and check the other thing. Then another feature that is very common within this map here, like now here we can find this I can say it might be a stream or a seasonal river. Then if you check here now, the person that did this work used a blue line to try to differentiate that this is a stream. Then the same thing happened here. If you try and check, if you try and zoom out, you see the density of the vegetation here. You show that this kind of physical feature show that there is a rivers that runs through this, that runs along this side. Then if you try and check now, then after the river there is a road beside it. You see this road, the same thing goes here. Then what we're not going to do now is that in the last time I taught you people how to use align. Then the same thing we are going to use here. We're going to use the align tools to align this thing perfectly, so that the person now will be able to use will be able to work within the working space he was trying to talk about. For example, now what is trying to complain is that, okay, let me try and offset 60 meter. This 60 meter, then you see 60 meter. This is a super block of a low density. Then imagine that a super block of a low density, then comparing to the length, to the length of a single housing unit. You see that it is, if you check the length of this building now, you see that it should be more than, I see this 95. Comparing to, then if you try to check the kind of housing pattern in this area, it is a high density area. Then I won't lie for you, there's no anywhere in Nigeria whereby the high density area in a high density building will be longer than the super block. It's not possible unless if it is a multi-purpose building like a public housing. Then like I said earlier, now you can see what the person is trying to complain now. Then he said the road with her perfect. Let me try and check. You see this 25 meter. Then here we have 37 meter. Okay, what we're going to do now is that I'm going to minimize these things so that we will be working with a tool, so that I'll be making the differences and similarity between the AutoCAD environment and the Google Earth environment. Then one thing I'm going to do is that I'm going to set a reference point from the Google Earth so that I'll be able to use it on the AutoCAD environment. So georeference this work that the person sent to me to help him to do with the work the person sent to me to help him to do. Then I'm going to remove this. Sorry. Okay. Then back to our discussion now. Then what we're not going to do is that we're going to look a common point within this AutoCAD environment and this Google Earth environment. A point that the same thing that they have in common. Like now, if you try and check this Google Earth, this road that we have a road here, and we also have the same road here now. Then we are going to use our place mark. Use your place mark. Use your place mark. Drag it to the center of this particular area that you want it to be. You want to pick the coordinate. Then now, like now, I'm going to put my I'm going to put my place mark in between the middle of these rows that go this way, because it shares the same similarity with this. You see, then for me not to get it done now, once you just have to know that before you do anything, before you do anything, make sure that you have already changed your go to setting and go to tools and check your coordinate format to be in universal transverse Mercator. I've already selected mine. That's the reason why but if it's your own, it's in decimal degree, try and change it to universal transverse Mercator. Then I'm going to drag this place mark in between this road. Then I've put it in between the road. Then I'll copy this eastern. I'll copy the eastern coordinates and use this to name. I'll use it to name this point. In other way around, you might create a text document and copy it inside. But because I will be trying to make the differences and similarity between these AutoCAD so that we know if the thing is now set or not. Then that's the reason why I'm now putting my coordinate. I didn't use text document. That's why I'm using the coordinate to name the place mark. Then I will now Ctrl V to paste it. Then I will Command 8 so that I will also copy the non-thing and paste it. Then once you do that one, just press OK. Then look for another point again that is also similar. That is also similar to the AutoCAD format, the same AutoCAD format. Then let me use this road. Because the road after the river. Then the same thing here. See, it look the same thing. How the things bend and how the thing. The formation of this road in AutoCAD is looking the same way how the formation in the Google Earth. Then what you're now going to do now is you click on the place mark, zoom out, and try and drag the place mark and put it at the center of at the middle point of the road. Then it is just an absorption, but one thing I'm very sure is that by the time we try to align this thing now, it will not going to be accurate directly like that. Then it's going to be like plus 10 meter or more than that, or it can be lesser than that. But believe me, it's going to solve the problem that's country. Then like I did to the other placement, I copy the eastern and paste it and use it to name the place mark. Then I'll put comma space, copy the nothing and use it to name the place mark. Then bam. Then the last time when I was trying to explain on my last lecture on how to georeference in AutoCAD, I said the best way for you to georeference in AutoCAD is for you not to pick only 2 points. Only 2 points. That you don't need another. If not like other GIS software that you can pick more than 5 points or 4 points to georeference, but in AutoCAD requires only 3 points. But if you try and use the 3rd point, it's going to highly distort your map you are trying to georeference. But that's why I advise you that if by the time you are georeferencing in AutoCAD, make sure that you always use 2 points. And that's why I chose 2 points here, this one and this one, and this special identity that I got from the Google Earth. Now that's what I'm going to use to georeference. Then what am I going to do is that I'm going to create on 9 L mean lines, enter. Then when I press L, which is line, then I will now, since this is the first point, now you can use anyone you like. It can be this, it can be this one. It doesn't matter whether you start from here or this here. But what matters more is that there is going to locate where this point in AutoCAD environment. Then what I'm going to do is that, then since you have already pressed L, which is line, enter, then we just have to insert this coordinate number by putting it accordingly. 290262.30. comma, to lock it and go to the second option, then 605050.30, enter. Yes, you can see now, you can see it dragged a line. What you just have to do is that forget about, just stop it anywhere you like. Notice one thing is that we stop it here because the reason why we stop it here now is because what we're after is the peak point, the starting, where this thing projected from is not where we stop. Where the thing projected from is not where we stop. Now then I'm still going to do the same thing to the second one by clicking on the line again, line, enter. Then when I click on the line, then I'll put the same coordinate number here, 291376.61, comma, then 605517.57, enter. Yes, then like I said earlier, now what matters most is where this line come from. This is not where we are stopping it. Then we can just stop it here or here, anywhere, but what matters most is that where the thing is coming from. Then what we're not going to do is that when I was trying to explain how to georeference in AutoCAD to you, I use a tool. I use one command called align. But one thing that we did on that in that one is that I selected on the image, then I press align without making this projecting these two lines. Yeah, the reason why is that it is better, it should be good when you are georeferencing an imagery. What you just have to do, you don't need to create this. You don't need to create these two lines because this is not an imagery. It's a lines. It's a features on its own, lines, and it's a polyline. And even in GIS software, you can't georeference lines. It's not possible. The only one thing you can do to the lines is that you move it, and that's the reason why. But we are going to use the tools of alignment command. By doing that, then we will alert on this. Once you alert on it, then we press align. You type align, you see align, enter. Then don't forget that our starting point is there. Just look for where the thing is, and the first coordinate that we projected is this one, which this is whereby this one is the second one. Then what you just have to do is that look for the middle, because we pick this thing from the middle of this Google Earth. Then look for the middle of it in AutoCAD environment. Then this is the middle here. Pick the center of this road. This is the center. Then take it to the first point that we created, which is this one. Then look for the second one. Then the second one is the road after the river, which is this. Then the center, click on the center and take it to the second point that we created, which is this. Then once you do that one, then what you're going to, because we are using align tool, like I said earlier on, it will be asking you to choose. If you try and check the AutoCAD environment, it's telling you to specify the third source point or continue. But like I said earlier on, don't specify the third source point, because once you do that, it's going to distort. It's not going to give you what exactly you want. But if you are doubting my explanation, just go ahead and try it. But for this lecture, for this tutorial, now I'm not going to do that. I'm going to use the tool. I'm not going to specify the third source point, whereby I'm going to right click. Once I right click, and it asks me to scale the object based on the alignment point, I say yes. Yes, now then I don't need this line again. I mean the line I used to project the thing. Just try and look. You see 4 at the center. Try and check the second one. You see 4 at the center. Then I can minimize my Google Earth, then maximize my AutoCAD environment. Then I can delete. I don't need this line again because I've already used it for what I want to use. I will now delete it now. Then let us now go back and try to measure this let us try and offset 60 meter now. Yeah, it's 60 meter. We still maintain it. Then you see now, you can see 60 meter now, different from the first one that we created. I mean, that we tried to correspond. Then you see now, then if you can remember that the 60 meter, then if you can remember, the 60 meter is a very small portion of area of land the right time when we did it, but now you can see now it is now bigger now. Then that's how to then as the work it is now, we have already solved the problem the person requested me to solve for him. Then let me try and just use any building that is very common in this Google Earth. Let me say, for example now, you can see this building now. You can see, if I see this building, then let me minimize it. Then let me minimize the AutoCAD environment also. Then let's try and look for it. Okay, you can see here, but the thing doesn't look the same. But let's just imagine let's just imagine. I mean, the shape of the building on Google Earth doesn't really look the same how the thing is on AutoCAD. Then what you're going to do is just let me measure the length of this building. Then by clicking on here and here, then go to measurement, set it on meter. You see, you can see 48.6 meter. Then let us try and check here if we can get a similar thing to what. Then di enter. Sorry, di enter. You see, this is 42.87. Yes, which may not, like I said earlier on, I said it may not be perfect, it may not be absolute, but it is going to be a plus, maybe +5 or +10 level of accuracy. Thank you for listening. I still remain myself. My name is Okpa Odusheso from ArcGIS. I hope you will really enjoy this lecture. Bye for now.